So far we have discussed the basic concepts which are related to file system interface, right? So basically, when you are at the starting of the file systems concept, these file systems are majorly deals with the concepts of files and how these files are going to be stored in the hard disk of the system, right? So that is the reason we broadly classified it into two parts. First part will be file system interface, where we have seen the concepts like what is file, what is directory, what are the operations of the file, what are the attributes of the file, how these files are organized, right? So this is what the file system interface will contain. And the second part will be file system implementation, right? Now in this particular class we will try to look into the concept of file system implementation. Right? So what does the file system implementation will define means, when an user interact with the files, or when user try to create a file, or when user try to open the file and try to update something, try to rename something, or whatever the operation that user is going to perform on the screen, that definitely have to be stored, right? That definitely have to be stored. If that storage mechanism is permanent storage mechanism, that has to be reflected back in the hard disk of the system. How the system will store the data in the hard disk will be known and understood in the concept of file system implementation. Among that, there will be one concept that we can say it as disk structure. You have covered this concept at DBMS, right? Have you remembered anything? Right? There will be a disk. And which contains vertical disk arm, right? It's a collection of various kind of sectors, and a plotter is there. On the top side as well as at the back side. Have you remembered anything? Right? So if you are unable to revise that, so I have the videos, just I will give those two videos, you can just revise them along with the get problems. Okay, so here the point here is why this disk arm is moving from one location to another location, in order to get the data, right? If you look into the CD, right? So you can able to tilt it, something you can observe some kind of lines, right? So that is where the data is going to be observed, right? You can able to observe clearly up to which location all the data has saved. Have anybody tried? Right? You can just observe the CD, just tilt it slightly, you can understood the part where it is full, you can something like a kind of black color, and the remaining will be kind of free. Okay, fine. So when the disk arm is moving from this point to back side, or it will move from towards right side, the data is going to be getting. See, I will let you know. If I say this is it will be in the form of various kind of things, right? So, and again everything will be divided like this, right? Each and every part I will call it as a block. Right? So if you want to access it, for example, I am at this point, my pointer. So in our terminal, if I say some pointer, I can call it as a plotter, which is always moving, right? If I want to get back to this location, first what I have to do, I have to move from this location to first I have to come to this track. I have understood? I am at this second track. If I want to get to this block, first I have to come to first track. This is what we call it as seek time. So you have to understand one terminology. seek time. Seek time means the time taken to move from one track to another track. I will call it as seek time. And once it reaches to this particular location, the time taken to move from this location to this location, it will call it as rotational latency, right? So you can go through that video where I can explain everything clearly, right? Rotational latency, which I can say this terminology, right? So anyhow here you have to understood that is when you are trying to store the data, that's okay, and when you are trying to access it, how much efficiently you are moving the plotter from one location to another location will define the efficiency of the access mechanism. Right? If you are able to store the data in an efficient manner, that will be the good one. Right? Which means that here before going to move, how disk blocks are going to be allocated, all the things. Let us see first how these disk blocks are going to be allocated. That I can call it as disk space allocation methods. Disk space allocation methods. I mean, when you are going to have certain free space is there. This is what I will call it as disk block. One disk block. Like that, many disk blocks are there, right? So what this disk space allocation methods will define is how you are going to allocate blocks of spaces to various files. That will be defined with various kind of factors. One will be contiguous allocation. What is the meaning of this one? In the earlier 5th unit also, how the memory is going to be allocated? Either in contiguous manner or in the non-contiguous manner, right? So the better one is what? Non-contiguous manner, right? So here also, how these disk blocks are going to be allocated means in the form of, one way is in the form of contiguous allocation, right? So suppose for example the same representation I am going to represent, let me take the another slide, disk space allocation methods, right? Among those, first one will be contiguous allocation, right? Suppose for example, if I take, this is a kind of a disk, and obviously you know, right, this will be kind of some kind of circular fashion. So anyhow, if I say these are the many blocks are there, let us take block 0, block 1, block 2, block 3, 4, 5, 6, 7, 8, 9, 14 and 15, right? So in contiguous memory allocation, how the data is going to be placed means, whenever any request will come for you, it will definitely has to be allocated in a contiguous manner only, right? Which means that, for example, there will be a file called test.c, and I observed that 5, 6, 7, from 5 onwards, many disks are continuously free. Then what I will do? I will allocate at the 5th location. And I will define how many disk blocks are needed. That will be defined by second one, which means that in contiguous memory allocation, how the data is going to be saved means in the form of tables. One will be the file name, another one will be starting disk block address. DBA means disk block address. Means in which disk block onwards I am trying to store, 5th disk block onwards, what are the sizes. What is the meaning of this one? By simply looking at this, test.c file has stored in the fifth disk, and from the fifth disk, how many disk blocks are allocated? 5, 6, 7 and 8. That will be defined by the size. So here size defines means count how many number of disk blocks are allocated, right? So in this particular manner, if I say jk.doc, which has allocated at 9th location, and assume that which was completed 7, is all are full? Yes or no? Yes. Next csc3.c, let us say it has identified that 0 is the 0th disk block is free, and then it has allocated for 3, which means that 0, 1, 2 are completed and 2 are left. Now csc4.c file is came into the picture, and it requires 3 files. And is there any free space is there? No, there is no free space. Only 3 and 4 are there, right? So can it fit here? No, it couldn't pass. So can I call this as external fragmentation? What is the exact definition of external fragmentation? When there is enough space, and if you are not able to accommodate it, that is what you call the external fragmentation. Does any enough space is there? No. So it doesn't call it as external fragmentation. Okay. No? External fragmentation means when enough space is there, but you cannot able to accommodate it. That is what you call as external fragmentation. Okay, fine. So this is how the contiguous memory allocation is going to work for you. Then if you look into the performance aspect of this contiguous memory allocation, like we can categorize in many aspects. One will be in the form of fragmentation aspect. What about the internal fragmentation? Does internal fragmentation is there here? Definitely, right? Internal fragmentation we cannot able to avoid it anywhere. Even in paging also, internal fragmentation cannot be avoided. Why? The last block might contains only few like very less data. So remaining data can be obviously wasted. So internal fragmentation is definitely existed. What about the external fragmentation? Is there or not? Yes, no. Why external fragmentation will exist? Suppose for example, here there will be 3, 4 and 13 and 14 are free. Assume 13, 14 and free are assume. Then there is a file, there is a kind of file with name cs4.c which requires only 3 blocks. But can we able to fit them here? No. If it wants to fit, it requires what? Continuous 3 blocks. But continuous only 2 blocks are there. This is what we call as external fragmentation, right? Even we are going to have 4 blocks of memory space available. I couldn't able to accommodate 3 blocks. We call it as external fragmentation, right? These are the 2 problems that we are going to face in the contiguous memory allocation. Is there any kind of problems that we can face? For example, let's say I want to increase the file size. Let's say test.c. I want to increase the file size test.c to 2 more count. Then can I increase it? No, because test.c is accommodated from 5, 6, 7 and 8, and immediately 9 is accommodated with what? jk.doc, right? So I cannot able to increase it, right? That is also one more drawback of the contiguous memory allocation. Is it okay? So increasing the file size is not flexible. I can say is inflexible. Any other things are there? These are the drawbacks, I can say, right? I am going to define all the things in performance only. And how we are going to access them? How we are going to access the files? Either sequential files or random access files or index files, right? here what is the possibility? Can I go with the sequential access? Yes. Once you know particular address, I can able to access them sequentially. Means I can start at 5th location, I can move to 6, I can move to 7, I can move to 8. Can I go with random access? Random access is possible because the data is available in the form of block by block. Because once I know starting address, see what is starting address here? See, once I know starting address is what? 5. I want to access the second block of the test.c. What I can do? I can simply add 2. Starting address plus offset is equal to random access. It is possible, right? So random access is not possible when you go with linked allocation. Why? The data is accommodated at different kind of blocks. That is the reason random access is not possible in the next level of explanation. So far you have understood that here sequence access is possible as well as random access is possible. The random access is possible because the data is contiguously allocated and you know its base address. If you go with the arrays, the simple example, arrays, can random access possible or not? Yes, that's the reason here random access is simply possible. Starting address plus and the offset. Next kind of disk space allocation method, that is linked. It is possible. That is also possible. Linked allocation. Right? So linked allocation will be comes under what, ma? Non-contiguous memory allocation, right? In the last class also I have mentioned, right? Paging, that will be simply connected to one array to one another, right? That will becomes under non-contiguous, where data will be distributed across different blocks, right? So if I say this is a disk, something like this. Okay, fine. Now, so linked allocation means what? For example, if I say there will be a file test.c that comes into the picture, and whose first data I can call it as starting database address or first database address. Let us say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? First database address is 5. And here we are not going to have count because it is not contiguous. It is not contiguous. We don't have any kind of count. And here we are going to have last database address. So last database address might be 8. Right? So now can you tell me, this is file name, can you tell me how many number of blocks are there in between the first database address and the last database address? Can you guess it? No. That might be 5, 6, 7 and 8 or 5, 1, 0, 4, 8. Why? Data is not contiguous. So based on the need, they might like here you have to add one more point. For every disk block, there will be one pointer. There will be one pointer that will be pointed to the next location. Point to next location, right? Which means if I allocated the first database address as 5, which will be connected to assume that as 4, which means it can be connected to this one. Next 4 will be connected to 1, so it will be connected like this. Next which will be connected to, let us say 2, it will be connected like this. Next if I say 8, let us say like this, and this is the end. Now you can understood how many disk blocks are there. Total how many? 4. What are those 4? 5 to 4, 4 to 2, 2 to 8. Is it correct? 5 to 4, 4 to 1. Good. 4 to 1, 1 to 2 and 2 to 8. This many disk blocks are required, right? So this is not only the exact path, you might add many kind of things as per the need. Hope you understood, right? So the reason why it is flexible, It is because of linked allocation, right? Whenever there is a memory free, you can just simply go to that location and you can place it and you can just link it, right? The last location, what is this \0? End, null character, right? So now in this kind of linked allocation, what are the various kind of performance things, or I can call it as characteristics also, no problem. What about the fragmentation related things? What about internal fragmentation? No. Always yes. Always yes. Internal fragmentation is going to be definitely there, which we cannot, right? Because for example, disk block size is 8 KB. I am going to use only 3 KB. Definitely internal fragment is going to be existed at the last block, not at the internal blocks. That also important. Internal fragment is always going to be existed in the last block of a file, but not in the internal, right? What about external fragmentation? No. The reason is, when there is a free, I can able to point to that location, I can fill it. There is no external fragmentation. And what about this one, increasing the file size? Can we increase the file size? Is it flexible or inflexible? Flexible. I can able to simply connect it to another location so that size will be increased. But in contiguous memory location, as immediately block is occupied by someone, I can't able to increase the size. Okay na? What about accessing mechanism? Is random is possible? Random is not possible, because if you want to go to the respective location, you definitely require its address, but that address you don't know exactly. You know only base address, right? So random access is definitely not possible. What about sequential access? Possible, right? So you can just analyze the concept of linked list, you can get the clear idea, those data structures. But the problems here are related to pointers, right? Pointers means what? Pointing to one location where the address, something like 4, 1, 2, 8 like that, right? So if one address is, if you are going to lose, what will happen? The entire data is going to be lost, right? Which means that file will be truncated. If a pointer address is lost, if pointer is lost, pointer address is not the correct one. If pointer is lost, definitely file will be truncated, right? So if you observe this chain 5, 4, 1, at the 1, if this is replaced with \0, then what about the remaining data is going to be truncated. We lost it, right? That is the one point you can understand. And what might be the another reason here? Can you guess? With respect to pointers, earlier case, are we going to use any pointers? No. So does pointers occupy some memory? Yes or no? When it occupies some memory, if pointers not there, that in that space can I accommodate more files? Yes, right? So that is one drawback here, right? So pointers will occupy, pointers will consume some memory. Pointers will consume the memory. So I can say it as there will be some memory wastage. There will be some memory wastage, right? Fine. So to overcome these drawbacks, again, to overcome the drawbacks of pointers and to overcome the drawbacks of access mechanisms, we are going to go with some other kind of mechanism. We call it as indexed disk block allocation. Indexed disk block allocation. Here, disk block allocation concept is a combination of contiguous allocation and linked allocation. Indexed and linked allocation. So what will happen here? Try to observe. In indexed allocation, generally if you go with the book, in book you are going to have certain index page, right? Index page regarding operating system textbook, right? So this is voice textbook. For example, if you go with DBMS textbook, it is going to have its own index page. If you go with the data structures, it is going to have its own index page, right? Similarly, if you are trying to store multiple files in the hard disk, for each and every file, you are going to maintain individual index. Right? When you are going to maintain individual index file, what will contains? It contains the addresses of disk blocks where they store. Address of the disk blocks where they store. See, for example, if I say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, assume that my file name, and I can call it as in which index block the respective file is going to be reside. For example, jk.c, it is 4. What is the meaning of this one? jk.c file is available in some other location, I don't know exactly, but if you want to know that location, you have to go with which location? 4th location. So which means if I elaborate it, which contains all the things. What is that? It might be residing in 6, 7, 9 and 10, which is a kind of linked list or not, right? So which will be this is what we call index allocation. I mean, if I say jk.c actually reside in 6, 7, 9, 10 pages, 9, 10 blocks, but to make them more flexible, we are going to refine only index block. I will go to the 4th index block where I can decide which are the blocks that data is available. Similarly, if I say csc3.doc, which is available at let's say 3, and this 3 block will maintain the respective things 0 and 1, like that, right? For each and every file, it's having own index block. That index block will define where the actual file stored, right? This is another kind of mechanism how your data is going to be stored. So what might be the performance thing here? Performance related to fragmentation. Does internal fragmentation is there? Yes. Blindly you can say yes, because obviously indexes may not be many, right? First thing, right? In the earlier class we have calculated many things, right? Indexes means something like addresses. If 4 addresses are there, how many bits are required? 2 bits of memory is enough, right? Like that. So if this block size is itself 4 KB, the remaining space is going to be wasted. Internal fragmentation is there. What about external fragmentation? No external fragmentation, which will be simply connected to one location to another location. What about increasing the file size? Increasing the file size. Is it flexible or inflexible? Flexible, right? Yes, right? If 4th block is completely full, then it will be connected to another block again. If 4th index block itself is also full, as paging, multi-level paging. If the main page table itself completely full, we are going to split again into page table 2, right? So the same process here also we are going to follow. And accessing mechanism, sequential access mechanism, because can we able to jump to one location directly? Definitely you have to go with only index block wise. Index block, then here you can go with any manner. Index block. So this will becomes under sequential access mechanism. And one more thing is, you have to go with additional space when you want to add more index block addresses. What is the meaning of last statement? If a file is occupied at many locations, sometimes this block also full, at that situation you have to add one more block as index file. That is what the meaning of this one. You have to add additional space to make index block. Right? These are the three kind of methods how your blocks are going to be allocated for the files. No need of any pointers. That is the reason only we are going to go with only sequential. Right? Yes, ma'am. That is the reason we are going to store it in only one location. Okay, now. So what will the button again here? What will the button? You have to have extra memory required for storing all addresses. Extra memory required for maintaining the index blocks. Okay, ma. So next one, disk free space management. Disk free space management, right? So earlier concept we deal with when there is a disk, when there are disk blocks, how these disk blocks are allocated, that will be defined by the disk block allocation methods, right? So if you want to allocate first, first you need to identify what are the disk blocks are free, and then how we are going to manage them. That will be defined by the disk free space management, right? Simply we can say that how you will manage free disk blocks and how much extra space are you wasting. In order to make identifying what are the various kind of free disk blocks. That concept will be defined by disk free space management. Okay, fine. Before going for the various kind of approaches, let's see first, let us say size of the hard disk or disk is 40 MB. Size of the disk is 40 MB and one disk block size 2 KB. One disk block size is 2 KB and disk block address size is 8 bits. Address is 8 bits. Can you calculate number of disk blocks are there, which is very simple. If you are able to practice the earlier class, how many number of disk blocks are there in the disk? Simply size of the disk means what? Total space. What is the total space? 40 MB, right? In that one block will occupy 2 KB of memory. This will yield to total number of disk blocks, right? So calculate it. So 40 into 2 power 20 bytes by 2 into 2 power 10 bytes, which is equal to 20K blocks, which is equal to 20K blocks, right? Total, right? Which means that is what I am explaining, right? If the entire block size is 40 MB, and each disk block is 2 KB. How many disk blocks are there? That is what my question. Total 20K blocks are there. Is the calculation is correct? Right? 2 power 10, 2 power 10, 2 power 10 is 1K and 220s. So which is 20K blocks are there, right? So if I am having these 20K blocks, now assume that all 20K blocks are free. 20K blocks are free. Then how we are going to know that these are the blocks which are free? Means, see, many requests you are going to get. Please allocate the memory for me. Like that you are going to get many requests, right? So once when you got a request, you need to allocate certain space. You need to allocate certain space, right? If you want to allocate certain space, first you have to know what are the free blocks. What are free blocks that you have to know, right? That is the reason we are going to know with the concept of disk free space management, right? So how we are going to know and how we are going to maintain what are the free blocks first. For that we come across with various kind of approaches. First one will be free list approach. Free list approach. In the free list approach, it is going to maintain. See, out of 20K blocks, some of the blocks are going to maintain for what? Maintaining what are the disk blocks which are free, right? So which means some disk blocks are used to store the free block addresses. Right? So if I say this is a disk block, this disk block will maintain the disk blocks which are free, right? If this is full, it will be connected to again another disk block, right? Now the question is at the worst case, how many disk blocks are needed in order to maintain what are disk blocks are free? At the worst case means what? All the disk blocks are free. At the worst case, all disk blocks are free. If all the disk blocks are free, in order to maintain these 20K disk blocks addresses, how many blocks are required? 20K into 10 or 20K by 10. What is 10 there? Have you understood my question? At the worst case means what? All are free. When all are free, I want to maintain all their addresses at one location. At one location or many locations. Then how many disk blocks are required? 20K blocks are there. These 20K blocks, 20K block, each block contains address, right? How many bytes it will take? 1 byte. 1 byte means, can I write like 8 bits? 8 bits by what? Block size. Have you understood this formula? Which is a simple numerical formula only, right? So 8 bits I can write it as 1 byte, right? Byte will be cancelled. That will be what? 10 disk blocks. Have you understood this one? Which means if I am going to have 20K blocks are free, in order to maintain, yes, this many number of blocks are free, and to maintain those addresses I need extra 10 disk blocks. Each are of size what? 2 KB. Try to calculate, again you will get back the same thing, right? This is the worst case. What about the best case? You have to compulsory have 1, right? So if anything is going to be freed, you have to compulsory accommodate, right? At the best case, you require only of size 1, right? This is a kind of free list approach. In free list approach, we are going to maintain what are the disk blocks are free. That thing will be defined by the free list approach. Next kind of approach will be bitmap approach. Bitmap approach. Bitmap approach. So in this particular approach, every disk block is associated with one bitum. Is associated with one bit. Okay, so I will write in clear manner. Associated with one binary bit, right? So why they will associate with one binary bit means this one binary bit will define whether the disk is free or not, right? So to know that whether it is free or not, they will maintain 0 and 1. If the disk contains 0, that will be called as free. If the disk contains 1, that will be filled with some data. Okay, now fine. So something like that. If I say right, earlier we calculated, right, how many disk blocks are free? 20k blocks are free. 20k blocks are free. Now how many blocks are required? In order to store these 20k blocks again? See, my question is, in the bitmap approach, like how many blocks are required to store these 20k block addresses again? Right, so 20k into 1 byte or bit here now. 1 bit. Each block will occupy only 1 bit. 1 bit by block size. What is the block size? 2k. Right, try to convert. I think 1 byte will be converted into bits. Right? Try to calculate. So kk also cancelled. 2 tens are 5, 4, which is around 1 point something. Around 1 point something. So 1 point something definitely required what? 2 disk blocks. Right? Earlier case what happened? Earlier case we got 10 disk blocks. Now it was reduced to 2 disk blocks. This kind of approach we call it as a bitmap approach. Right? So here we are going to reduce the number of blocks usage additionally. Next one will be counter method. Right, so this counter method is the most efficient one, where this counter method will simply maintain what is the first free disk block address, what is the first disk block free address, and what is the count of next contiguous disk blocks. Next contiguous disk blocks. What is the meaning of this one? If I say first disk block address is 5, what is the count of next contiguous disk blocks free? Assume that 3. What is the meaning of this one? Continuously 5, 6 and 7. These 3 disk blocks are free. Right? This is the better one. Right? If I say 50 and it is 100, what is the meaning of this one? From 50 onwards, 100 disk blocks are continuously free. So this which will take very less amount of memory space compared to bitmap approach and the earlier approach. See here in the bitmap approach you can calculate worst also, right? So this, in the worst case we got 2 disk blocks. In the best case here 1 disk block is required. Why it is worst case? We assumed that all 20k blocks are free. That is the reason you got 2 disk blocks. But in the best case, you required 1 disk block. Okay, no? So here, try to observe based on the disk block size. Based on the disk block size, many factors will affect them. Is this statement is true? Right? So if the disk block size is very small, disk block size is very small, what about the space utilization? Is more. Why space utilization is more? Because we can avoid maximum times of what? Internal fragmentation. Have you got this point? Right? For example, my requirement is only to store 1 KB, but there is 10 KB of file, 10 KB of space. Definitely memory is going to be wasted. But if the very less space, definitely we are going to utilize the space for some other thing, the remaining. So that is there I can call it as space utilization is increases. But when one is advantage, there will be some disadvantage also there, right? What about the throughput? Decreases. Why throughput decreases? Very good, right? So when disk blocks are more, trying to access the disk data from the multiple blocks will take more time, right? Because the plotter has to move from one location to another location, so accessing will be more. As accessing is more, taking more time, I can say that throughput is very less, right? But if disk block size is very large, this is important actually in terms of competitive examination. When disk block size is large, space utilization is definitely decreased because internal fragmentation will be more. Internal fragmentation will be more. And what about the throughput? Increased. Throughput will be increased. Okay.